I wanted to do a quick demo of a system I wrote that assists with configuring Choria servers, that is the new replacement server for Inflected Daemon, in environments where you do not have configuration management, or where you have scalability issues that cannot be solved with configuration management. It's called the Choria provisioning service, and you can get it on GitHub. It's open source, of course, like everyone else, and it's easy to extend. So I wanted to do a demo of that, talk a little bit about what it does and how it works and its flow, and show you that in action today. Basic idea is that you might have multiple locations of nodes, different networks, different customers, different regions. Perhaps even within one region, you could have multiple brokers because scalability concerns or just different teams, internal facing, external facing, for whatever reason. The permutations in large enterprises tend to become very, very complex. And of course, that's reasonably well solved with configuration management and systems like data in HereUp, but without the help of those, it's rather difficult to solve, especially at scale when you wish to provision thousands or tens of thousands of nodes an hour. And there, the system can help you, at least for the purposes of Choria. Later on, we will show how to plug those into further configuration management systems, but for now, we're focusing on just configuring Choria. We have here isolated networks, Sydney, London, New York, and we have a provisioner. The provisioner is perhaps global, or perhaps one for APAC and one for Americas, or so forth. It doesn't matter. But effectively, this is where you will place your logic, your CAs, and so forth, and that is where you decide how a node will be provisioned, what certificates it gets, and you will sign those certificates, and so forth. So node starts up. Doesn't have a configuration, or the configuration is invalid. And so it looks at its compile time defaults, and it finds your provisioning network, and it goes and connects to that provisioning network. Once there, it will start publishing events. These events will have your facts, metadata, whatever. You place a file on a disk, you tell the thing when you compile it where to find this file, and whatever is in there will be published to anyone who's listening on the provisioning network. Now, in my case, these files would have things like facts. It will tell us in which data center the machine is. It will tell us which customer it's for, what kind of machine it is. Perhaps you have a pod-based architecture. It will tell you which pod this machine belongs to. These are information placed there during node provisioning, either through your cloud metadata or something similar. However you get the facts there, it will publish it. And there, the provisioner will listen, the provisioner will get these facts, and it will start interacting with this node. It will make RPC calls. It will ask the node to produce a CSR and send the CSR back to the provisioner. The private key, of course, never leaves the node. The CSR gets sent to the CA and it gets signed. The CA could be any CA. It doesn't need to be a CA that we support. You'll see later on how that works. And any CA with an API, basically. Once signed, once you've made all of the decisions you need to make about the configuration, you package it all up into a configuration package, deliver it to the machine, and it configures itself, restarts itself, and now it connects to its final destination. There it lives like a normal node. It will reboot, all this kind of stuff. It will use this configuration that you've given it. Configuration is written to disk. It will not interact with the provisioner or connect to the provisioner again after that. Now you may have a reason to reconfigure a series of machines. Perhaps you wish to decommission their broker infrastructure, or you wish to, for whatever reason, reconfigure them. You can publish an Rpc request to them. This Rpc request will tell them to re-enter provisioning mode. They will null out their configuration, and the process will start afresh. But otherwise than that, the node will continue running, will be in a state, and the provisioner will continue to listen for events. The provisioner will also, though, regularly scan the network for machines ready to be provisioned. And when I say network, I mean the Choria network. doesn't send packets to any nodes. The reason for that is you can defer provisioning if you wish on specific nodes, or a node may have just not had facts yet, and so it didn't have any event to send, so it was missed, or something went wrong in sending the event, who knows. Whatever reason, there is a regular sweep running that will find orphan nodes and attempt to provision them again. So I'll show this in action and talk a little bit more about it in the next segment of the video. So if we take a quick look at this running in a Docker Compose demo, I will boot up this machines. And what's starting up is one broker for the provisioning network, one broker for our quote-unquote production network, and one Choria instance. I will take a quick look at this already started up. We have our Choria starting up here. Choria starting with a specific configuration. It enters provisioning mode because it doesn't have a valid configuration. And we can see it's going to connect to a machine called provisioning broker. It connects there, it does this thing. Let's quickly look. Now it will then publish, as soon as it's up, its metadata, which comes from this file here, to the network. It doesn't know who, it doesn't care who. And the provisioning broker got that immediately. As soon as it started up, you can see it received an event from this node, and it started through the provisioning process. It went very, very quickly, less than a second, at which point the server restarts itself and it connects now to the production broker, which is the configuration it was given. See the configuration up here: middleware host, production broker, server provisioning is off. Just that, those 3 lines is all that was configured. And it's up, and periodically, as I said, the provisioner is checking for new nodes. Let's scale this. Well, let's first start a shell. Now this shell is connected to the production network, and we have just the one instance there. Docker compose scale Choria to 10. Now it's going to scale this network up for us. And they start up, they connect, and we have our 10 machines. Let's scale that to 20 machines. Again, they're starting up, they enter the provisioning flow, and we have our 20 machines configured. Now that is a complete life cycle. Everything got done there, machines completely provisioned, everything is done, basically. We can have a quick look at this, so you can see what is configured. I'll make my screen a bit bigger. The provisioner YUM, it starts 4 workers. This means it can configure 4 nodes in parallel. It runs every 1 minute. It will do a soup of the network to try and find those orphan machines. No logging. It has a helper, which I will show in a second. And the token is a pre-shared key that you compiled into the binaries. Obviously, in this early provisioning phase, you may not have any SSL set up. It may be running even without TLS, that's fine. But the traditional Choria security mechanisms wouldn't function in that environment. So we support this concept of a token where you compile a token into the binary. This tells the provisioner that indeed the network that is connecting to the network where it's provisioning on is insecure. In other words, it doesn't do TLS, and it shouldn't try to do any of the built-in protocol level security stuff. Site, we will talk about that in a second, and this demo is probably unused. It exposes Prometheus monitoring on port 80800, which I'll show you in a second. And in this instance, I'm not integrating with any PKI. Let's have a quick look. normal Prometheus metrics here. And you can see we have things like how many discovery cycles were done, busy workers, how many machines were discovered via events, all the times, the time every different RPC record is taking, lots of really interesting stuff. And I have a dashboard which I will show later on in this video. But yeah, so that is it. It's super lightweight. I'm not on the correct machine now. Let's have a quick look. Provisioner. See it's running there. It's using almost no memory, and this stays reasonably stable. As you provision hundreds of thousands of machines, and it's very quickly. So yeah, that's it. That's it in operation. There's not really a whole lot more to say. It does embed something called the Choria backplane, which I will do a video about later. This backplane allows you to do things like circuit breaking, so that, let's say you have multiple of these provisioners running across your infrastructure, you can have all of them connect to a core backplane Choria infrastructure, and there, using the Choria backplane, you can pause them all, resume them all. You can find if all of them are up. You can do health checks and so forth. And if ever there is a problem where you notice the wrong thing is being done to your nodes, you can circuit break the provisioning of nodes, and they will all pause. No events will be received. Well, they'll be received, they won't be processed. No discoveries will be done. Any halfway provisioned machine, it will just stop. It's a nice big red button to get you out of trouble if ever there's a problem. Now, the provisioner is a generic tool that works for everyone, I hope. And the way it works is using a helper. So let's look at our helper. Now, our helper is super simple. It doesn't actually do anything, but the helper will receive on its standard in the node's inventory, and that includes what versions of Choria it is, what agents it's running, its facts, any of the information that you wish to expose about a node. It will be received as JSON format on the standard in of the script. You decode that, and now you can programmatically make any kind of decisions you want. You can communicate with your own asset databases, anything you want. Inside the standard in data will also be the CSR of the node if you've configured PKI. And so you can at that point do whatever you want to do to sign that certificate. If you have Vault, if you have CFSSL, if you have any enterprise CA that might have an API, you can interact with that. Now, if you wish to not configure the node at this time, you can set defer to true, and you give it a reason. You tell it, CA unavailable, or maintenance window, or untrusted node, or whatever. This will be logged in the provisioner. It won't go to the node. Otherwise, you respond with a configuration, which is just key value, string versus string key values of exactly what you would put into the Choria configuration. And that's it. So you can see that you have complete flexibility to configure anything you want, any model you want, integrate with any tools you want, any databases, any CA, any API that you wish to integrate with, you can integrate into the provisioner. This is your single extension point in the provisioning process. You provide the script, and from there on, it drives anything. Of course, it could be written in any programming language with the capability of reading JSON on standard in and putting JSON on standard out would be sufficient. That is all. You can code it in anything. They would be called concurrently. So in the event, if you're integrating with a CA and maybe your CA has a concurrency constraints, you should implement that in your script through maybe a lock file or something along these lines. In any event, the script has 10 seconds to run. If it doesn't complete in 10 seconds, no provisioning will fail. So just keep that in mind. But this is your interaction into the system. You don't need to write any RPC stuff, nothing like that. You only have to focus on the task at hand, which is what is a Choria provisioning config. And that's basically it. That's the whole system. I will shut this one down, and that's all there is. I'm going to, while this is going on, I will put up an image here of the statistics as a dashboard. I showed you that the machine is exposing Prometheus data on its monitoring port, and if you scrape those in, we provide a dashboard that you can load into your Grafana, and there you can see all the timings for the helpers and the RPC requests, and you'll be able to see how many nodes are configured, how many busy workers there are, um, error counts, all this kind of good stuff. Yep, so that's it. That's the project. Thank you very much for your time.